Hello, everybody, and glad to see you in webinar number 3 again. Today, we want to talk about the stages, model, and simulate, and hope you still can remember that the applications from RPC Pro are now called stages in RPC Connect. So as the following outline shows, we want to focus on some differences between RPC Pro and RPC Connect and introduce some new functionalities to you. So as you might know, this webinar is too short in order to show you all the new features and changes we have, but we try our best to give you a good insight to the new software RPC and the RPC Connect features. Again, it's all about, as Josh mentioned, about the efficiency in your lab. And as you can see here on that nice little picture on the right, RPC Pro is now getting to switch off, and we are going to start RPC Connect. So don't lose any time and start with webinar number 3. Here's a brief look at the stages we have in RPC Connect. So last time we spoke about setup and analyze, and this time we are going to talk about simulate and model. And as you know, we need all the stages to finally run our durability test. So model and simulate are kind of enablers to finally run our durability test in that so-called test stage. Again, let's have a look at the overview I created last time to emphasize where the stages from RPC Connect are contributing to. So here we clearly see that RPC sends signals and collects data from our controller. So the controller is sending these signals as an output to an MTS rig here, evoking a movement of the actuators. And in return, all the transducers send a feedback, which is the controller to the controller, and sends it to RPC again, which we all know as our system response. So imagine we play out our simulate drive and then measure our simulate response. With the help of that data, we can calculate our FRF and hence use it to understand our system behavior, and that is model, of course, the model stage. And to recreate these scenarios we measured outside of the lab, we need to pass the well-known iteration process, which you all are familiar with, of course. And during the iteration process, we have to analyze our data and inspect the results. And this is the simulate stage, of course. So let's start with the model stage and explore some new functionalities here. As you know from the last webinar, we will see some slides showing the RPC software and then hop into the software for some hands-on examples. During this webinar, I will pause, as Josh already mentioned several times, to answer your questions. So please feel free to type them in the Q&A sessions. So let us briefly remind us what the model stage is used for. So the model stage takes care of generating and analyzing the FRF. It's creating our inverse to make it possible to understand our system. It's deciding on which frequency bands RPC should intervene, so how the drive is changing or should be changed by the help of RPC. And we create a mathematical relationship between the rig and the input and specimen output, so our inverse FRF. And just to mention it again, so here it's important to remember that remote doesn't refer to a distance, so it's not a physical distance, it's more a dynamic distance, and output is distant by spring, by masses, and by dampers. So it's basically speaking the decoupling between input and output. Okay, the first thing you recognize will be when you change from RPC Pro to RPC Connect that my next button is gone. So due to the new way of error messaging, there is no need anymore for a next button. So once you get used to it, you will love it. But what is this so-called real-time validation? The real-time error validation permits to get rid of the next button. So in RPC Pro, you only if you use this next button, you got a kind of error message shown. Directly switching with the help of the tabs did not give you a feedback, and the operator was not seeing if anything is wrong. So let's just go through an example that everybody knows what I'm talking about. So now I'm opening RPC Pro, and then we are in the model stage defining our drive shape. And now imagine we have a lower cutoff frequency here, and we want to define our drive shape. And I make something stupid typing in like low cutoff frequency of 5. So everybody knows that the break frequency has to be higher than the lower cutoff frequency, of course. But RPC is fine with that. RPC Pro is not arguing about that. When I switch here to the drive amplitude and then go to the execute tabs, we don't see any problems here. So if I hit the next button, the validation starts, and now I get an error message, and RPC is telling me that here's something wrong. So if I type it back to 0 again, which is normally the right thing, or let's say I can go to 1, whatever, it's still right, but RPC is still showing that there's a kind of error. And hitting the next button will solve the problem while rechecking it. So all cells here are only checked when you use this next button. And that's the only reason, or let's say the main reason why the next button stayed here. But now in RPC Connect, as we have 3 different types of error groups, I want to show you in a second, we have another way of handling this. So this is the same tab as we saw in RPC Pro. So we are going to define our drive with the drive shape here. And let's give us some space. I maximize this window here. And what you see here is, again, the same rig which I had in RPC Pro. So the start frequency is 0, the break frequency is 2. So now I do this exactly the same as I did in Pro. So I type in a 5, and then hit enter. And what happens, it's a real-time validation check. So what it's doing, it's telling me here's something wrong. So the start frequency for left longitudinal is invalid. And of course, it might be the case that I just forgot to change the break frequency to a higher value. So it might be that this one is wrong as well. So it's checking both. And if I need some additional information, what the problem here is, I just go to the error log here, and the error log will directly tell me invalid break frequency for left longitudinal, break frequency 2 cannot be less than the start frequency. By that information, I directly know where the problem here is, and with the help of these validations, you exactly know what you have to do or what is wrong in your settings. So this is really a good helper, and we have 3 kinds of values here. So the one which you saw right now, so this rectangular, this red circle with a white cross here with a white X in, is a symbol which needs to be fixed. So it's not a kind of warning character or information character. It's really a character which shows an error which needs to be fixed. Otherwise, you can't run any tools or anything in the wizard here. So I need to change it, and then it's okay. Let's go for an example in the resample tool here. So just imagine I have a time history here. So let's just select the Simul drive, for instance. And now you can remember from the last webinar that the fully resolved name was consisting of the output time history, the identifier, and the suffix. We call these 3 parts here the fully resolved name. So it says that the input time history will be called Simul drive. And finally, if I hit run and close, I will get a file called Simul drive resampled. So now imagine if I just remove the resampled one here, the input name and the output name become the same. So in this case, Simul drive. And now you saw that there's a warning exclamation, which shows me that the input file will be overwritten. So this is a kind of warning character you have in RPC Connect, showing you are going to do something which might be a mistake, but if you're sure, you still can run the tool or execute whatever you're trying to do. So this is basically showing this kind of warning character. And the information character, I might have shown that last time. This will exactly show you on different things in the tools itself, what you are trying to type in and what you are trying to use. So for example, the frequency shift is, this value specifies the maximum frequency shift in the case of non-integer sample ratios, for example. Or if we just choose for another tool, let's say the sine wave generation or whatever, and you want to know what is a sine dwell, it is just basically shown here and telling you what you are going to type in. And these kind of information characters you're directly finding in each tool or during the whole software. And together we call this the real-time validation. All 3 parts will help you to be more efficient in your lab and understand and not going for any undocumented errors anymore. Okay, so far, any questions here?
There is one quick question, Safa, related to RPC Pro, which I can answer. So the question is, our site currently leases RPC Pro licenses. Will this still be an option once RPC Pro is no longer supported? To make that quick question a long answer, I would say So we released our last version of RPC Pro last month. That's RPC Pro 5.5. That will be the final version of Pro that's released. However, as I mentioned at the beginning, we will be supporting RPC Pro even after the Connect launch for the next several years at least. So the answer is likely it will be supported until your operation system no longer supports Pro, aka anything up to and including Windows 10 will likely still continue to support RPC Pro. So hopefully that answers the question.
Okay, thanks, Josh. Anything else?
Nothing that I can see. Anything from you, Paul?
No, proceed.
Okay, sounds great. Then we hop on to the next slide. So in both stages, we implemented a so-called wizard, but you're asking yourself, what is a wizard? The wizard is a guideline which will bring you through all the necessary steps you need to pass to reach your aim. And in model, of course, it's our inverse FRF we want to have. The wizard is also checking with live validations if your settings are correct to use. So the mistakes or the error messages we just discussed, they will be grouped and summarized in the webinar, in the wizard itself. And you directly see where your problems are and why you can't execute any tools. The main goal of these wizards is to bring new people easier up to speed and help to increase your efficiency during your work. And therefore, a lot of important functions from RPC Pro, which were hidden in the option sections, are brought to the wizard surface. So, for instance, in RPC Pro, you needed to be an expert to know where all these hidden functions are. For example, the clipping factor, the repeats or fixed seats, whatever here. You need to go through all these options and all these tabs and try to find the appropriate function you were searching for. So now, for instance, in the drive section here in RPC Connect, we directly see that you can type in your drive shape. So we are again, sorry to mention that, we are again in the drive shape section here, which you saw from my previous example where I changed the start frequency. So this node shows you directly the clipping factor, the points per, the repeats per frame, and the drive lengths right away. So everything is summed up on the important parts and everywhere where you need it, of course. And by the way, the replication code here, which you see here, is kind of the fixed seats options we had in RPC Pro, but it is like an advanced fixed seat. So as you know, while the amount of energy present in the time history does not change when different seat values are used, the exact placement of the random data points does change, of course. And with a replication code, you can recreate the same drive file each time you generate a new drive using the same drive parameters. Okay, so this is just type in any number, any word, what you like, and you exactly get the same white noise depending on the things you typed in. Okay, and now here's the wizard model show. So we need to go from the first node down to the last. The first option here is, of course, to select the setup and ask yourself, how often did you choose the wrong setup and measured the FRF? So this is the past. The first check is the right setup selected. And in my last webinar, I mentioned that the picture is connected to the setup. So this is another indicator for having the right setup selected. In this webinar, we do not have time to go through all the points of the wizard, but the important ones I will show to you. So let's discuss some of the points of the nodes we see here. And for those who ask themselves what the interactive model processor is, no worries, we will discuss about this during this webinar. First important note is that the control channels and bands one. So this is the first important one we want to talk about in this webinar. Imagine you are in the inverse tool from RPC Pro. So we see here on the left side the input channels, on the right side the output channels, and as usual the control bands and control frequency bands are on the top of the tool, as you know from RPC Pro. So this slide here emphasizes that the control and the no control settings can be chosen directly. So there is no need to go through the control bands after each other. In RPC Pro, it was the case, for example, here you needed to click on 0 and then the frequency goes up, the control band goes up to 25 Hertz. And if you wanted to make your control and no control settings, for example, here on the input side, you just had this first column, which you see here. And now having several control bands, you directly see them up next to each other in the subsystems here on both sides for output and input channels, and you can set them right away. So this is, very efficient to work with the control bands, and this has improved much in RPC Connect. Another topic which was really disturbing in RPC Pro is the way of logging how an inverse FRF was created. So in a lot of tests, you ended up with more than one FRF. Sometimes you might even have 12, 14 different FRFs and which try to make your system converge. However, the main problem is to trace back which channels are in control, what settings did I choose in the inverse tool, and you ended up with a long fancy names in the end, not knowing exactly what you did. And finally, you opened these matrices here, and then you scrolled through the channels in the plotter itself, and then found out that which channel is on control and not control. And for that reason, we invented, or one of the reasons is we invented the interactive model processor. And the aim here is to get a better overview how the FRF was created and what parameters were set here. The smarter channel selections when calculating FRF is possible now, and with the help of this node, you can keep track of all the defined control set and save them in the part of a project. Let's go for an example here. I think you already recognize that it looks quite similar to the inverse tool, but if we go into the software and have a look at the interactive model processor here, it makes much more sense. And okay, so if I check this box here, the interactive model processor will directly be run after measuring the FRF. If I don't check it, I can use it just like the inverse tool. And now let's have a look what happens here. So as last time in my last webinar, I used the 329 with 2 corners. This time I have the same system running in the demo mode again here in the back with our 793 software. And the first thing is to do, let's just make an example here. It's just an example showing you how to work with this interactive model processor. So imagine you had a person who is driving like, let's say, he's a very sportive driver. You can go up to a frequency of 3 with the steering wheel, and then we control the brakes till 35, which seems to be a good number here. And then our final frequency, which we are interested in, and all the damage is kept into our time history, will be into our system, is a frequency of 50. So we get 3 subsystems, we get 3 different control band settings here, showing directly up. And then what we are doing is we're just setting, let's say, the steer on no control, on control for 0 to 3 hertz. And then we go up and say here, no control for the further parts here. And this steer on the other side as well, just an example here. And for the brakes, we do the same, except we just want to have it controlled to 35. So we say the left brake and the right brake will be just controlled up to a frequency of 35. So these are the settings I made, and now I can go to the right side and do my settings as well and have some examples here. And so whatever we have, let's say we put the MZs here on no control and no control, and we just define our settings. And now we have let's say a second FRF, which we expect to work better, and we just give the first FRF the first inverse we are going to create is FRF Sportive or FRF Sport. And then I just click this plus button here to get another FRF. And this second FRF will carry over all the settings I just made. So all these settings are here, and I can make the minor changes I'm expecting to have. In this case, I say, okay, this is somebody who is not very sportive behind the steering wheel, and I'm just going up to a frequency of 1.5, or I'm sorry, it's the English version. I think I started here. I'm sorry. No, let me copy that one, whatever. And then you can make your changes here and define your new FRF. And this one is then called FRF Slow. And then you get a second FRF. And now you can imagine if you have like several ideas how your system can converge and how you want to start your iteration process and be successful, you can add a bunch of FRFs here with different control sets. and hitting the run and process model button will create each time the FRFs with the appropriate settings. So if you have a simulation filter set, if you have set the H2, for example, which you see here, everything will be created and given a name. So in this case, let's say we are going to have this FRF Sport. It will be called Simult H1 here down on the right bottom here, Simult H1 FRF Sport Inverse, and accordingly the FRF, the forward and filtered ones, etc., will be generated and directly seen. So this is a way of getting a lot of FRFs later on to work with, and you have a kind of reminder how they were created, just going back into the interactive model processor, clicking on the specific FRF and seeing what settings were made. Okay, it's a lot of fun to work with that tool, so try it out once you got the software on your system. Another thing we are going to talk about is in RPC Pro, we had the so-called correlation channel. So some of you might have realized while I was clicking in the interactive model processor on the systems, on the subsystems, you didn't see the correlation part here. And these channels, correlation channels were, of course, channels which did not contribute to the drive chains, but were visible during inspection or observation purposes. And in RPC Connect, we got rid of them to be part of the inverse. That is important. So we did not completely got rid of them. We got just rid of them, be part of the inverse, because this brings a lot of benefits for the software. Now, all the channels defined in the setup are treated as correlation channels. So correlation channels don't need to be part of the inverse anymore, but still can be seen during the iteration process. And the benefit which comes along with that is that we don't have any gains to set for the correlation channels anymore. You can remember yourself when you were in Pro and you were setting some gains on the correlation channels, it didn't have an effect, but they were still there somehow disturbing. So this is the past and is not valid in RPC Connect anymore. The benefit which comes along with this new treatment of control, no control, and correlation channel settings is that you can resort, add, or reorder channels you need during the iteration process in so-called on the fly. The inflexibility in RPC Pro is that the number of columns in the inverse, so the rows of H1, for example, always had to match the number of channels coming out of the setup. As such, addition or modification of these channel lists for simulation would always involve the creation of another inverse. And in a case where you just wanted to add, let's say, the output of the valve command or any other channel which comes up to your mind, you need to actually rerun the whole process, go through setup, go through analyze or through model and measure a new FRF. And I mean, we all know that when we have a 329 with 4 corners, an FRF can take up to 1 hour to measure it. And just for one channel I forgot, I just want to add to as a correlation channel, it doesn't make sense to go through all that process. So this will save a lot of time. And in RPC Connect, only control, or what we say candidate for control channels, appear in the FRF or in the inverse. And candidate typically means that they are tuned on or turned on for control in some regions along the timeline and are turned off for control in other regions along the timeline. So control channels were convolved to form an error, and no control and correlation channels were convolved to form zero with zeroed FRF terms. But nonetheless, they were processed just through the inverse convolution process. Okay, but how can I add the channels on the fly then? Let's just have an example here. I go back through to my FRF here, and then we say, oh no, let's maximize this one. For example, you just go to the response section here, and now let's say we are going to just have an iteration based on my wheel force transducers. So here, these are my wheel force transducers, Fx, Fy, Fz, and then the according moments to that. For 2 corners, of course, you have these channels twice, or let's say on the other side twice, more or less. And then these are, let's say, parts and rig things which I'm not interested to because they should not be part of the inverse and I'm not using them. I just want to monitor them or just kick them out. You just go here, say response post process, and then once you've selected that one, you just go here And then with the help of minus, plus, whatever is in your mind, you can just, in my case, remove these channels here. And what happens is RPC will resort it, so saying, okay, these are only channels I'm interested in. And then in the interactive model processor, oh, I didn't hit that button, sorry. Now I hit it. So RPC is loading. Let's wait a second. Oh, what happened? Well, we will give the software a second. Pretty confident that it will make it. Yeah, perfect. Sorry for that. Something is going in the back. Maybe the IT is installing new software again, something like that. Sorry for that. So now I removed the channels, and in the interactive model processor, or just in the inverse itself, I will get only the channels I'm interested in. So these channels I can now use to have then no control and control, and yeah, directly use them. So only for these channels later on in the simulate wizard, I will set the gains. Whereas in RPC Pro, I needed to set everywhere gains. Okay, it is as easy as shown. Let's go to the next slide and see what happens here. So now we have a greater flexibility in defining the response channels in model itself. So additional actions to add, remove, sort, which I showed you right now, is just pretty easy from the existing setup or from a time history. You can just grab it and yeah, select it, the channels you are interested in. And once you got yeah, your response analysis process set, you will just get this signals which contribute to a drive change during your iteration process. Any questions here so far before I hop on into the simulate stage?
Yeah, a couple questions came in, Safa. The first one I see is there a seed number in RPC Connect that gives the same seed as the fixed seed in RPC Pro, parentheses, so we could make the same model drive?
So yeah, if I get the question right, it is asking for, the person is asking for, we have the fixed seeds here, right? I hope this is the question, which is, I hope I got the question right. The fixed seed is always creating one white noise with the same, let's say, random signal. In RPC Connect, this change here, which you see if I go through the replication code here. So if I type in, let's say 1, 2, 3, 4, it will generate a fixed seed, so to speak. So one right noise with a random time signal. And if I type it in any other project, or in 10 years later, I type in the same number, I will get exactly the same white noise. So if I choose for something else, let's say MTS test, this one will generate another white noise, another white random noise, but exactly the same one if I use always the same replication code. So no matter on which computer you type in MTS_test, you will get the same white noise and can compare it to each other. So this is pretty cool too, when we add some channels, or I had something set up wrong here and I want to recheck, I just added a channel or something and want to recheck if the parameters stayed the same and compare simul drive, let's say previous and simul drive current with each other. I can type in this replication code and then lay both over each other and compare them. Okay, any other questions?
Yeah, two others that I can see. The next one is, when one channel has no iteration to others, is it possible to write some word instead of control/no control? For instance, break?
Mm-hmm. Yeah, of course. So this functionality, which you are familiar with from RPC Pro, is still staying. So for example, if I type long X here, and that one, I create a subsystem for the longitudinal channels here, long X, and then now these are in the same subsystem. So this behavior still stays the same. You can separate the subsystems if you want. So now I have the subsystem with long X here for these channels, just writing that in. Yeah, that is still possible.
Great. And then the last question I can see is, how do we see correlation channels?
Yeah, so if you want to see correlation channels, is exactly the point where I'm going through. It will be in simulate. So This is really based on here, what you see here is really based on the model functionality, so on our inverse. And give me a couple of minutes and I think your question will be answered then, how to see correlation channels. If there are no other questions, I will hop into Simulate and try to answer that one.
One other question, Safa.
Mm-hmm.
Are you still able to type into the no control fields so we can create standalone subsystems? If we type in a custom name, will it show up in the dropdown?
Yeah, of course, of course. Now it's in a drop-down here. So as you see, long X is here, and if I want to select it here, it's long X is here. Okay, great. Then let's hop on to the simulate stage. So let's have a look at simulate. What can we do here? What is new? What new functionalities do we expect here? And again, here's a brief reminder for those who are not very familiar with the simulate stage. The simulate stage enables to recreate real scenarios occurred outside of the lab being reproduced inside of the lab with the well-known iteration steps converging the system response to our desired. And here's just an example where the black signal, the black sine wave signal here is our desired or now called target signal. And this, oh, sorry, the EDT signal before in RPC Pro is now called the target signal. And you see the blue one here. This is somewhere middle of the iteration process where you see the current system response. And what we're trying to do with the simulate stage here is trying to make the blue signal converging the black signal, of course. And this needs to be step by step. The first thing which I unfortunately already mentioned is very important to know. So MTS changed the file suffix name from EDT to TGT, which stands for the target and seems to be the right terminology. So take care during import changing your old EDT files from RPC Pro into TGT, otherwise they will not show up in the list, which you are familiar with Pro. So when you switched from, when you went into Simulate in RPC Pro, you needed to end a suffix called EDT, otherwise RPC would not find it. In this case, for RPC Connect, it's called TGT. Just like the model wizard, we got a simulate wizard, which will guide you through the iteration process. And our experienced users will directly see that all important steps are listed here and will guide you through the process. Again, I will just highlight some features here to give you an expression of what you can expect from the new RPC Connect software. While setting a target, RPC Connect asked for the target and response channels. So target channels are the channels defined by your target file or previously called the EDT file. The response channels here, these are the channels defined by your active setup. So the names can vary here. In RPC Pro, it was very easy to play out the wrong file content to the wrong channel because the depending of the file itself was on the RPC Pro setup. So let's go for an example here. Imagine this was your EDT file here in RPC Pro, and these were your response channels in RPC Pro in the setup. It might be the case, let's say this one here on the top left is a longitudinal signal, and you had in your response channel, you had the first channel was the lateral one, for example. So RPC Pro would just map it here and say, I play out whatever is inside of this signal here, I play it out to the first channel of the RPC setup. And that might cause some troubles because if you didn't take care of that, you played out the wrong file content to the wrong channel. However, in RPC Connect, we did it a little bit different here. So we have now the automatic and the manual process. And what is the benefit of having this question at all? So if a target and response channel names are the same, just use automatic as seen here. This is the automatic one. So RPC Connect will take care of it. And if the target channel names and the response channel names are in different order or are different, use manual method. So the benefit here, which you see, is you don't need to use any header modification tool or make, let's say, the EDT match the setup. I know it was not necessary, but most of our users try to adapt their files to the setup or the other way around to make sure the right channels are played out. And this brings the kind of flexibility into the software. So now what happens? So not having these mapping features leads into RPC Pro into such some constraints. So for example, if you had an FRF which was 8x4, so 8 response and 4 drives, the FRF or the inverse FRF was of course a 4x8, and the desired response could not have should be at least or should be exactly 8. And that was really a really big problem, because if the model did not match, you got this famous model dimension mismatch, which you see here. So just you needed to make sure that everything fits. And in RPC Connect, this is not the case anymore. So what you can do is you have a greater flexibility to just have different target channel names count against the active response channels, and you can just sort them in the way you want to have it. Once measured, you can resort them in the way you like to use them, and there's no kind of fixed place or fixed thing which the software just allows you to do. So Connect provides also the ability to have different target channel counts against the inverse middle dimension here. So in the model stage, I told you that it is possible to change the channels on the fly. And this brings a benefit for the simulate stage as well. A change in the target file, as long as the channels are added to the end during the iterations, is possible. In Connect, target channels counts can be different from the active response setup channels. But one remark here: target channels must be a subset of the station response channels. So let's go through an example to just see what I'm trying to explain here. So if we close the model stage here, go to the simulate stage. So let's have a look. So it's pretty easy just to, now we have a 12x12 system, for example. And if I want to, let's say, this is the simulate wizard, and I want to use more channels than I have in the inverse, as I'm doing right now here, I can just select them here in the post process and say, okay, these are the channels I want to work with. And now the question which was previously asked in the seminar here is, all channels which are listed up here, they will be treated as correlation channels. So all channels I show up here will be go through the iteration process and just shown as a correlation one, which you are familiar with from Pro. So, and if I now decide to have my FRF was a 12x12, and I decide to have a 12x26. I just say, okay, here the same thing I did in model stage. I select the post process, and then I am able to the post process, and then I'm able to remove channels, remap channels, and whatever I like to do here. So yeah, this is some kind of flexibility we have here. And then finally, in the end, oh sorry, I was on the wrong node. This was covering here. So finally, in the end, depending on the settings I made here, the selection of my channels will show up here. So in my case, I have 44 channels here. And during the iteration process, I even can switch them and change my target file and switch the channels and still continue with the iteration, depending on what I said right now. That one thing is taking into consideration that the target channels must be still a subset of the station response channels. Otherwise, it's not working. So here's an example shown that we had previously a TGT file with 20 channels, and now we just added 2 additional measurement channels because I'm interested in what is the specimen doing there at that location, and I just want to measure it and see it later on in the system response. You can just add them on the fly without going back and measure a new FRF, which was definitely in RPC Pro necessary. Okay, the next important change in RPC Connect is the damage node in the simulation wizard. So if you are using the same specimen for iteration as for durability purposes, it is most important to know what damage the specimen already suffered from. So iteration process, as you know, can reach very high numbers before converging, and hence the damage should be tracked somehow. And this is now implemented into RPC Connect as the damage node. If you check it here, RPC will calculate the damage depending on the settings you made. So you're having the classical damage options from RPC Pro available here, of course, and can monitor what the damage your specimen already suffered from. Okay, Another thing I want to talk about today is that RPC Connect now offers a new way of going through the iteration process. In RPC Pro, you could choose for automatic iterations, hence the same gains were used for the same number of iteration sets. Now imagine you have a similar specimen or strategy how to do your iterations. Now in RPC Connect, you can schedule the iterations in advance and maybe, let's say, go and drink a coffee or go out for lunch, and the software is working for you. But don't tell this to your boss, because I think it's not always good to know that the software is doing something on its own. And now let's have a look what the software is changing here and what I'm talking about. Now I'm going back to RPC Pro. I don't save this one, going to the simulate stage. And now what the hell is the automatic iteration I'm talking about? Let's bring everybody on the same page here. I start RPC Pro, showing you where the automatic iterations are. So we're waiting till the floating windows here all appeared. And so now I'm in the execute tab here, showing the number of iterations, and here are my gains. And what I did is here, when I typed in number of 10 and hit enter, RPC Pro would just go with all the same gains, 10 iteration steps. So there was no way of defining these gains during my iteration process. Now let's go into RPC Connect and have a look how it looks here in RPC Connect. Again, I'm in the run iterations node, and here are the automatic iterations, which are the same as from RPC Pro. So if I type in a 10 here, you will see that this node here, or this lines fill, and we have like starting from 0 to 9, we have 10 steps using all the time the same gains which I have here. So same behavior as RPC Pro. And if I now, let's say, had a specimen which was quite similar to the one I iterated 3 months ago, let's say we had a twist beam or a multi-axle beam, which I was interested in. And I know, for example, on the 329 that the FY signals will at the beginning not converge, and later on they need to be adapted in the gain scheduling, for example. Then I have a certain strategy which I can use to copy and paste in here and work with that right away. So for example, let's say at the beginning, for whatever reason, I'm going to have the FYs with a low gain here, and for example, let's say the FZs with a higher gain. And then just imagine I did that once and have a whole set of iteration gains ready to just directly use. I'm going that for, let's say, 2 or 3 steps. And then on the 4th step, I say, okay, now if that is converging well, I'm fine with that one. I reduce that one a little bit and say, okay, 0.2 is good. And now I want to increase the FYs. And I have the feeling that this will make my iteration process successful. So I go here and use that one for several numbers of iteration steps. And then in the end, I will say, okay, I now need to have everything on 0.4 for this region here, and then I'm fine with that. So this is some kind of scheduled iterations I can set in advance. So you see that RPC saves all that gain settings I just made. And if I hit the generate load drive and run button, it will go through all these steps and just use the gains I have here. So in a lucky case, let's say if you're a lucky iteration specimen and you already know you're a really experienced user and know how to cope with that specimen, you can set your iteration scheduling in advance and finally got the iteration running on its own, not hitting in limits. And let's say this is how RPC should work. And this makes your work with the help of the software much more efficient and good to know. So the last point I want to talk about, or we are going to talk about today, is the finish node in the simulate wizard. As you all know, the fin drives will be available to create a sequence in RPC Pro. So all files which you have with this _fin here, they contributed, can be used in the test application or test stage, as we call it now. They can be used for creating your durability run. And the first thing you typically do in test stage is to have a reference run or to get somewhere some values for your trend section and point-by-point monitoring, or even spectral if you use that one. And now in RPC Connect, you have this include response button. And this include response button is in order to get your reference files already ready in the test stage, which we will talk in the next webinars, of course. And this file enables you to, let's say, copy and paste some values for your trend files or some values which are appropriate to set any limits, because typically the last response, of course, is the last reference you have before starting your durability test. And if nothing changed or everything is still fine without any cracks at your specimen, these limits should be still valid, right? And now in RPC Connect, you just click on include responses, you get connected, so you get the drive file, gets a so-called reference file, or include the last response, which you can carry over to the test stage and work with that right away. Okay, now I would say it's time for some questions. And yeah, thank you for listening so far.
All right, a couple questions that I see here, Safa. So just circling back to one that we had earlier, is there a way to see correlation channels in the model stage and not the simulate stage?
So it's still in. So I mean, where's the difference in seeing it in model or in simulate? Because where you are interested is when you are in the model stage, you are interested in all signals. So let's put it here and do not save it. So if you are interested in the model stage, for example, what you can do here is, you mean, I hope you mean, or you're referring to the subsystem shows you a control band, which is, let's say, as my example showed, between 2 and 35. Let's see, I didn't think I saved it, but we can recreate that one quite fast. So if I, let's say, have a control band here up to 35 and then another one up to 50, and you set these ones on no control, you go through the simulation filter, and then you have the options here to set whatever you want, to pass everything or not pass everything. So depending on the settings you made here for your simulation filter, it will of course adapt your settings here. And yeah, there we have a no control pass and control pass, and I think that one will be going too much into details. We need to have a separate session on that. But of course, you can still in model see some channels which are on no control in certain areas here, but it is meant to have them in simulate, just to have them as control channels, as correlation channels, if they don't contribute to the drive. So if it's really a just monitoring channel which is not changing or contributing to your iteration process, this one will be set as a correlation channel in simulate, and these channels here, depending on the settings you made here, of course, will still show up as correlation channels as you are used to. Hope this answers the question. Any other questions?
Yeah, a couple others that I can see. So does RPC Connect keep record of the iteration gains? So if they were to go back at a later date, would they be able to see what gain scheme was used for each channel?
Yeah, of course. So if I have the scheduled iterations, which I showed you a second ago, so I'm going back to simulate to show what I'm talking about here. The gain scheduling is kept for each project. So if you save this one here and open new project, so let's go to the run iteration node. Sorry to open so many windows, but I just switched the stage. So I think what the question is asking for is, if you have these channels here selected and you change something here and go further here to change something in that area, these changes will be all saved after you close that. Let's say this is one project car number 1, and you have a second project called project car number 2, and you go back to the simulate stage of this car number 1, you will definitely see the changes or iteration gains you have here. You even can just copy and paste them into the new project then. Okay, any other questions?
One last one that I can see here, Safa. So are the iteration gains saved in a file? So for example, if they were developing multiple tests running the same type of sample on different Connect workstations, could they copy over the gain scheme from one to another, or would they have to re-enter the values into the other workstation?
Okay, as far as I know, but I'm not 100% sure. We have many tools have now implemented the so-called, you see this little gear here in that area. These are the tool settings, and you can load, save, reset them. And as far as I know, but I'm not 100% sure if this is release 1 or this will follow in other releases, we will give an answer to that. But as far as I know, it is planned in further releases that this little gear will occur here as well, that you can save it in a file and then import it as load settings from, let's say, project A, B, C, whatever. You just select the file and import the scheduling here. But I'm not 100% sure now. We need to answer that question with the help of the team, because I don't know what the final decision is here. Okay, any other questions?
Yeah, there's a couple other ones that I can see here now, scrolling down. So in run iterations, can you schedule different models to be used as well as gains?
So if you go here to the map area, so the map region area, let's make it full size. You can select for your different regions, of course, different inverse selections here. But if you're asking if I can, let's say, have for the run iterations node, let's say step 1, another FRF, then step 3, this is not possible as far as I know.
Can you change the model with iteration scheduler?
You mean, oh, that the question should be more precise. So what I know is, of course, maybe you're referring to Turbo is adapting the inverse, of course. And these gains here are not adapting on its own. If you have Turbo off, of course, you will use your FRF, which your inverse FRF, which you measured, and these gains will be applied. So it's still the same process, multiplying the gains, multiplied with the inverse, etc., to get your drive estimate for the next step. So this will stay the same.
So can you set different inverse models to be used for each automatic iteration step?
No. As far as I know, it's not possible. So if you have like step 1 cannot get another FRF, you can only work in regions. So depending on the region selections you made, let's say you have a chuck hole event, or you have a signal which has weird data content in, maybe we just import something. Let's do it here. Let's just maybe import any file I can find on my computer here. What do we have here? Let's go for RPC Connect. Maybe I have something here ready. In the webinars, I think I had something here for webinar 2. Example files. Let's go for, let's take the EDT here. Just imagine you had some kind of signal like this. You might imagine that this section here, this area, needs to have another treatment or another FRF. Then maybe this part here should be different than the other parts. What you can do is you can just simply mark them, and then, of course, create your regions as you are used from RPC Pro. And then once you created your regions, you go back here and you will see that you have, let's say, this is then 2, and then I add another region, and then you can say, okay, I have region 1 inverse number. Okay, I have no inverse now imported here, but you can select here several inverse as usual. So this is the only way. You can't go to the run iteration step and say this number 4 gets inverse number 4, number 8 gets inverse number 8. That is not possible.
Okay, 2 other questions that I can see here quickly. One, will the gains also be stored if the gain scheduling is not used? So if they only enter gains step by step?
Yeah. So we can go through an example here. So if you say, okay, I remove these here, and then you say, okay, 0.2, I start with 0.2 for all cells. I copy them to all cells here. And then I say, next step would be something like, 0.4 here, 0.4. And then the next step will be 0.6. Let's go for that example here, 0.6, 0.6. So now if I scroll back, you will see that it kept the gain scheduling here, and of course it will save it. And if I now click on that one and say automatic iterations, few more numbers, it will of course get the last gains I used and then repeat them, as you know from RPC Pro. What you can do as well is set here, I'll insert a copy of the selected iteration and then say plus, and it will insert a copy of the selected iteration. The question, however, is, does it make sense if it's on the end when you're using some of the previous ones? But this is now, of course, depending on the situations you are working in.
Okay,
Anything
and
else?
then the last question, does the gains history text file still exist?
That's I need to check, to be honest, but we can do that in a second. It was in the other folder as far as I know. So let's go to the Project Explorer and check it. So as far as I see here, I did not run any iterations. Let's run a step here. Hopefully that works. I'm connected. Let's see, generate row drive and run. Okay, I have something empty here. Let's try to make a fast example here. And then, map the regions again. So I need to bring in an inverse fast here. Let me see if I have something ready for you guys here. So let's just copy that one here, whatever that is. At least we get one iteration step. And then say, okay, select that one here with the current inverse I have, select the filter. So, and then now you have the correlation filter here. All paths will show all the signals and all the stuff I have here. And then we run one iteration step. And then it should create a gain file, but I'm not sure if this is currently there. By the way, this is a new plotter here. This will show the current and previous drives laid over and show you the difference. So once you have the first run, you will see different colors here, emphasizing that one drive is bigger than the other one, and you can directly see if it's like 20 times higher or not. So in percentage of full scale, of course. Okay, what's happening here? I should switch off the limits to be successful, because on my demo system, it's not working with limits, I think so. So let's run one iteration step. Will take 5 seconds here. It's a short signal we are going to iterate. By the way, you can directly use another target file and then switch it and continue with your iteration. So if you have something seen which is wrong in your target file, you had some wrong channel order or whatever is occurring, you can just go to set target, and then RPC will ask if you want to continue the iterations, depending on some restrictions, of course, but depending on the iterations, you can continue from the step where you were. Okay, back to the question. Now I went through one iteration step, I go to the other folder, and it is empty. Okay, that question we need to answer later on, but as far as I see it from now, the gain text file is not existing anymore. But maybe you can copy it from that schedule here to the text file and copy it somewhere and create one pretty easily. But I will ask the team and bring it as a, let's say, proposal to change the system behavior here.
And then 2 other questions came in here just at the end, Safa, quickly. So if an iteration is rerun with different gains, will the damage accumulation be calculated correctly?
Oh, so if you rerun it, you want to keep the damage and then continue with the damage and add it to the damage you previously have measured already. Need to defer to the team. I don't know. I can't answer that question. Sorry for that. I will just log the question and see with the customer, and we will, after the meeting, take care that we answer that one.
Yeah, we'll follow up on that one. And then the last one, can a target be changed or modified during the iteration process?
Yeah, we can do that quite quickly. So let me just create a sine wave here and say, okay, we were one step, we already had one step here, and I will create another file called webinar2 TGT, say run and close. And then now I go through the target back here and say I changed my target from target webinar 1 to target webinar 2. And now RPC is asking, do you want to continue iterations or restart iterations? And depending on the choice you make here, I click on continue iterations, then the run iteration node stays where it was with the gain scheduling, everything is the same, and we continue. And I guess, that's only a guess, the damage will be the same, but that we need to clarify here.